Black holes suck. Black holes have a gravitational pull so intense that not even light can escape their clutches. They drain the life out of stars, ripping away layers of gas and shredding the component atoms. They are often portrayed as vast cosmic vacuum cleaners, capable of clearing huge areas of space. However, the black holes of science fact and science fiction are not entirely alike. In reality, black holes behave almost exactly like any other massive object in the universe. The speed required to escape the gravitational pull of an object, whether it's a planet or a black hole, is known as the escape velocity. For an object like the Sun, with a modest gravitational pull, an object only needs to travel at a speed of 384 miles per second to escape. If this speed cannot be achieved, the object will fall back down toward the solar surface. At the event horizon of a black hole, even something traveling at the speed of light, almost 186,411 miles per second, would not be fast enough to escape, and the only option would be to continue inward. The singularity at the center of a black hole is the ultimate no man's land, a place where matter is compressed down to an infinitely tiny point, and all conceptions of time and space completely break down. And it doesn't really exist. Something has to replace the singularity, but we're not exactly sure what. As you move farther from a massive object, the escape velocity decreases. In the case of black holes, when you're far from the event horizon, their gravitational influence is no different from that of any other object of the same mass. For example, if the Sun were replaced by a black hole of equal mass, Earth's orbit wouldn't change. It would continue circling just as it does now. Objects that pass by at a sufficient distance and speed won't be drawn in. Earth is closer to the Sun in summer. Most people know that the Earth doesn't travel around the Sun in a perfect circle, so it is easy to see why some make the leap and assume that the seasons are caused by the distance to the Sun. But the idea doesn't hold up when you think that the northern and southern hemispheres experience summer at different times of the year. Earth's orbit isn't as elliptical as people imagine, and over the course of a year, the distance between Earth and the Sun varies by just 3.1 million miles, 5 million kilometers. That's only about 3%. During winter in the northern hemisphere, we are actually closer to the Sun than we are in the summer. The real reason for the seasons is the axial tilt of the Earth. As the year progresses, light hits the northern and southern hemispheres at proportionally different angles and for different amounts of time every day. During the winter, the days are short, and the light strikes the atmosphere at a low angle, glancing through the gases as it travels toward the surface and spreading out as it reaches the ground, distributing the energy. During the summer, the days are much longer and the sunlight hits the Earth at a steep angle, taking a more direct path toward the floor and concentrating the energy into a smaller area. The moon has a dark side. The dark side of the moon has inspired studio albums, novels, television series, films, and video games, but the moon is not quite what it seems. We only see one side of the moon from Earth, but just because we can't see the other side, it doesn't mean that it is dark. Looking at the phases of the moon easily disproves this myth. During a full moon, the side that we can see is fully illuminated, and the other side really is in complete darkness. But at any other time of the month, we can only see part of the moon. The rest of the light is falling on the far side, or the so-called dark side. As the moon rotates and orbits around the Earth at the same speed, it means that humans looking up at the night sky will always see the same side of the moon. So when people talk about the dark side of the moon, they're actually talking about the side that's always facing away from Earth. The dark side of the moon actually refers to this being mysterious and unknowable to astronomers in the past. This has only changed relatively recently, as crude capsules and robotic probes have been able to send back images of the previously hidden side. For photographic evidence, you only have to look at the first-ever images of the far side of the moon captured in 1959 by the USSR's Luna 3. Not only do these images dispel the myth that the dark side of the moon receives no light, but they also show that the rock is actually lighter in color than the side that we can see. The Great Wall of China can be seen from space. The Great Wall of China is the longest human-made structure in the world and spans an incredible 13,171 miles. The idea that it might be visible from outer space is a popular one and has been around since the 1930s, but unfortunately it is only partly true. The Great Wall might be very long, but of course, it's not remotely as wide at just over 20 feet at its base. Not only that, it is constructed from materials that blend well with the surrounding terrain. In low Earth orbit, which starts at 99 miles altitude. The wall is easy to pick out on radar images, but is invisible to the naked eye. During his time on the International Space Station in March 2013, Commander Chris Hadfield tweeted, "I did not see the Great Wall of China from space, and neither did the Chinese astronauts. With a big enough camera lens and clear air, maybe." The myth existed long before the space age, long before Yuri Gagarin's famous flight to become the first human in space, and long before the Apollo missions to the moon. In fact, as early as 1754, the famed English scientist William Stukeley wrote in a private letter about the Chinese Wall, which makes a considerable figure upon the terrestrial globe and may be discerned at the moon. The sun is yellow. As every toddler knows, the sky is blue and the sun is yellow. Even though you should never look directly at the sun, photographs reveal a yellowish hue, and when you look up on a sunny day, a distinctive orange tinge appears as the sun dips over the horizon at night. However, this yellowness is just an illusion. The sun produces all wavelengths of visible light, and therefore its true color is white, but as sunlight travels through the atmosphere, it changes. The wavelengths of light at the blue end of the spectrum are much shorter than those at the red, so collisions with particles in the air are more likely. During the day, blue light scatters high in the atmosphere, giving the sky its blue color and making the sun appear yellow. In the morning and evening, the light that hits the ground has farther to travel, and this effect becomes more extreme. Most of the shorter blue wavelengths scatter before they hit the ground, giving the sunrise and sunset its characteristic red-orange hue. Stars and constellations are close together. The stars in the night sky are arranged into 88 constellations that represent 29 inanimate objects, 19 land animals, 9 birds, and a dragon. These recognizable groupings have guided farmers and travelers for thousands of years, but in terms of proximity, they are not really groups of stars at all. Despite appearing to be close together, the stars that form the constellations are often separated by tens or hundreds of light years, extending backward into space. From our vantage point on the surface of the Earth, Orion might look like a warrior with a shield, but from elsewhere in the galaxy, the stars would look distant and unconnected. They vary in age, size, type, and brightness, and it is by chance that we see them in groups. Constellations might not be important scientifically, but they help us divide the sky into easier sections. By turning star patterns into shapes of animals or objects, it's simpler to remember where stars are and what they're called. The asteroid belt is very hazardous. There's no doubt that there is a lot of rock in the area of our solar system, known as the asteroid belt. Sitting between Mars and Jupiter, this band of fragments contains over 3,000 minor planets and more than 750,000 separate asteroids measuring more than 3,280 feet. The larger asteroids sometimes collide, spraying smaller fragments into the belt. This myth has been fueled by science fiction. When Han Solo takes the Millennium Falcon into an asteroid field in Star Wars, The Empire Strikes Back, C-3PO warns,
"Sir, the possibility of successfully navigating an asteroid field is approximately 3,720 to 1.
If the Hoth asteroid field was anything like our own, he couldn't have been more wrong. In the 1970s, NASA's Pioneer 10 became the first spacecraft to navigate its way through the asteroid belt. Only a layer of aluminum honeycomb protected Pioneer, but despite the apparent danger, it made it through with no trouble. Not because of careful evasion, but because the distance between asteroids is huge. The belt spans an area of space approximately 140 million miles across. On average, there is a distance of around 600,000 miles between the asteroids, which is more than twice the distance from the Earth to the Moon. A much bigger danger in the asteroid belt is the dust-sized particles that form when asteroids collide. These tiny grains could definitely cause damage to the spacecraft. Light isn't affected by gravity. Gravity is an attractive force between two objects with mass and light and is transmitted by photons, which have no mass, so light can't possibly be affected by gravity. But if this is true, how is it that black holes can prevent light from escaping? The laws of gravity that we know were the work of Isaac Newton, who said that gravity is a pulling force that works when both objects involved have mass. However, Albert Einstein overhauled this theory by suggesting it was the result of the shape of the fabric of the universe. These curves don't just affect objects with mass, but light travels so fast that the dips in spacetime have little effect on it. But black holes create spacetime curves that bend toward infinity, so not even light can climb out the other side. Earth's shadow causes the lunar phases. It seems plausible that the lunar phases are the result of Earth's shadow, but the moon is often visible alongside the sun during the day. So what's really causing the lunar phases? They are actually the result of the sun rising and setting over the visible side of the moon as it orbits Earth. During a full moon, our satellite is on the opposite side of Earth to the sun, so we see the sunlight illuminating its entire visible surface. While during a new moon, the moon comes between Earth and the sun, so the light falls on the side that we cannot see. In the intervening days, the amount of light that we can see on the lunar surface gradually increases and decreases with the orbit of the moon. A lunar eclipse is the only time that Earth casts a shadow on the moon, and these rare events only occur if Earth comes exactly between the sun and the moon, temporarily blocking out the light. The sun is burning. Fire needs three things to survive: fuel, heat, and oxygen. The sun has fuel as it is composed mainly of hydrogen and helium gas. Helium is an inert element and does not burn like some of its volatile neighbors on the periodic table, but hydrogen is highly flammable. The sun also generates an enormous amount of heat energy, and its surface is about 9,932 degrees Fahrenheit. However, there is no oxygen in space, so the fire triangle is incomplete for the sun. In reality, the sun isn't actually a ball of fire, and instead, the heat and light that it produces are the results of thermonuclear fusion. Inside the high-pressure, high-heat environment of our star, high-speed hydrogen atoms come within 1 femtometer of each other. Don't forget to subscribe to the channel if you liked. Thanks for watching this far. See you next time.